Next is paragraph type questions, in which it is given that let ABC be three sets of complex numbers as defined below. A is Z1, where Z1 minus 2 iota, modulus is less than equal to 2, and B, where real part of Z2 minus imaginary part of Z2 is greater than equal to 2, and C says that mod of Z3 minus 3 minus iota is greater than equal to root 2. So let's firstly draw the graph. For A, it has been given that, so the circle is like this, where it is touching x and y axis, and its center is 2, 2, and this point is 2, 0, and this point is 0, 2. So this is A is area inside this circle and the points lying on this circle. Now let's talk about B. Let us say Z2 is equal to x plus iota y, then it is x minus y greater than equal to 2. So let's firstly plot the line x minus y equal to 2. So it will pass from this point 2, 0, and it will pass from this point, that is 4, 2, right? So the line is something like this, right, which is passing through these two points. So the area is definitely lying below this line, that will be set B, which means that A intersection B is this part, right? Now let's talk about C, that is center is 3, 1 and radius is root 2. Now 3, 1 is lying on this line, so its center is lying on this line. So the graph is something like this, let's say, where this is the center 2, 2, okay? So now Z3 is area lying outside this circle. So if we talk about A intersection B intersection C, then we are not getting any area, just the points P and Q, right? So we are getting only 2 points, that is P and Q. So number of elements is 2, so correct answer is option number C. So this is our curve here. Now question number 52 says that let S is equal to A intersection B. So A intersection B is this shaded region, right? And Z4 is lying in this area S, right? Now we have to find the incorrect option. So option number A says that area of the region represented by S. So this area can be found by firstly finding the area of this quadrant and then subtracting the area of this triangle, right? So area will be equal to pi by 4 into r square minus area of this triangle, that is half, into base into altitude, so that is pi minus 2. So option number A is correct. Now option number B says that number of solutions of the equation argument of Z4 equal to pi by 18, that is 10 degrees, is 2. Now for this area, minimum argument is 0, right, and the maximum argument, that is 4 OQ. So let's firstly find argument of OQ, that is tan theta is equal to 2 by 4, that is cot theta is equal to 2, that is maximum argument is cot inverse 2, that is theta is around 26 degrees, right? So we are talking about 10 degrees, so 10 degrees is lying somewhere here. So for these points we have infinite points here whose argument is pi by 18, but it is saying that it is 2, so this option is incorrect. So this is our answer. Let's check the rest of the options also. So number of solutions for pi by 12. Pi by 12, it is also lying in between this region, so its number of solutions is infinite. This is correct. And maximum value of principal argument is cot inverse 2, which we have already found, so this is also correct. So answer is option number B. Next paragraph, it says that let A is equal to Aij 3 cross 3 be a matrix formed by 9 distinct non-zero real numbers x1, x2, x3 up till x9, each number used once in a matrix. So the sum of the values of all the determinant of matrices A is, see, total number of matrices of this type that will be formed is 9 factorial. Now we have to find the sum of the values of all these determinants. If we make grouping of all these determinants, let's make group of 9 factorial by 2, right, 2 times. So we will definitely have a particular determinant, right, and for that particular determinant we can exchange the rows and we will get a new matrix, and the sum of those two determinants will be negative of one another, that is its sum will be 0. So in this way we can see that the sum of all the values of the determinant will be 0. So answer is option number A. Next, question 54 says that if x1, x2, x3 up to x9 are first 9 prime numbers, then we have to find the difference between maximum and minimum value of the trace. So let's firstly write down the first 9 prime numbers, and those will be 2, 3, 5, 7, 11, 13, 17, 19 and 23, right? So these are the 9 prime numbers. So to find the maximum value of the trace on the diagonal elements, we will keep these 3 elements, and for minimum value of trace on the diagonal elements we will keep these 3 elements. So we have to find the difference of those two, that is 17 plus 19 plus 23 minus 2 plus 3 plus 5. So this will be equal to 49. So correct answer will be option number C. I hope all the questions are clear to you. Let's now discuss paper number 2.